Alright, welcome everybody. So today we're going to talk about the periodic table. This is a nice periodic table lunch table that you can use if you go to Wake Forest University in North Carolina. But let's get to this here. First we're going to start with a little bit of history of the periodic table. There are some new scientists here that weren't here before. The first one that you may not recognize is Dobereiner. And what Dobereiner looked at were something called triads. And so this was early on. People were just discovering elements and thinking of ways to categorize them. And so he came up with his law of triads. And what he noticed was that when he looked at elements in sets of three, that they had similar characteristics. So, like for example, we could do like calcium, strontium, barium. And today we know that they're in the same group and they have similar valence electrons, or same number of valence electrons. So that's why they're similar. But he noticed this, three elements together. I mean, you could do this also. He noticed with chlorine, bromine, and iodine, and with sulfur, selenium, and tellurium. So these were what's known as triads. It was early on, but this is an important thing that the IB exam in particular would like you to know. Some fun facts like this. Then there was Dr. Newlands. And what Dr. Newlands saw was that he called it his law of octaves. And then what he saw with this was that, every 8 elements or so, the properties of the elements would repeat. So they'd have these repeating properties. So these were two early scientists. And so he would group these, Newlands would group these elements together. 8 elements would have these repeating patterns. Dobereiner will look at them in terms of triads. The first real breakthrough came from a scientist called Mendeleev. And what Mendeleev saw was that the elements could be arranged by atomic mass. He also actually looked at properties of the elements too, and he would use, oxide formulas to help. Organize the elements. But what we use today, and the law that's, or the scientist that really came up with the general idea that we use today, is Moseley. And he arranged the elements by atomic number. And this is known as the modern periodic law. And what the modern periodic law basically says is that when you arrange the elements by atomic number, they have this regularly repeating properties. And so this is kind of where we're at. And we know that, when we look at the periodic table, that when the elements are arranged in their atomic numbers, that we see, certain characteristics emerge from them. And they happen in this periodic way, hence the term periodic table. And the two main characteristics of the periodic table, the two, ways that they're organized, the elements are by group and by family, by group and by period. So when I look at the group, this is a column, a vertical column. And I show you this vertical column over here. Now, why are they arranged in this column? What does it mean? Well, it means that they have the same number of valence electrons. And so if I'm in group 1, for example, then I will have 1 valence electron. If I'm in group 2, I will have 2 valence electrons. If I'm in group 13, or what's known as 3A, I will have 3 valence electrons. If I'm in group 14, or what's known as 4A, I will have 4 valence electrons. And this goes all the way through to 18, or 8A, where I'll have 8 valence electrons. Now, what we notice about, these elements, because they have the same number of valence electrons, that they have similar chemical properties. And so elements in the same group or family, they have similar chemical properties. Now we can also arrange elements in a horizontal row, and that's called a period. So a period is a horizontal row. And here I show you period 4 and period 5. And what's similar about these elements, or what's the same about them, is that they have the same number of principal energy levels. Now, there are 2 periods in the periodic table that are separated, and this is called the F block, and we saw this in the last chapter, how you have the different blocks of elements in the F block are separated. This is just mainly to save space. We could put this in, and then the periodic table will be shifted all the way to the right. But now, instead, if I have this, then we can save space, and we can fit the whole periodic table on one page. Now, you should know some basic facts about the periodic table. And this stuff is just pure memorization, so I'm going to go really quickly through it. You can spend your time, sitting and reviewing them and knowing these facts. So you should know where the metals are. This is on the left-hand side of the periodic table, except for hydrogen. Now, in the periodic tables, there's this staircase, and this is where the metalloids are. And so you have elements, boron, you have silicon, you have germanium, you have arsenic, you have antimony, and you have tellurium. And these 6 elements, these are metalloids. And then you have the nonmetals. And so the nonmetals are on the right side. So you have the metals on the left of the staircase. You have the staircase, which are the metalloids. They separate the metals from the nonmetals. And then you have the nonmetals on the right-hand side. Now be careful, because sometimes they're like gases, and that's not necessarily true. Different elements, whether a metal or a nonmetal, could have different phases. For example, for liquids, we have the metallic element, mercury. So there is the possibility for a metal to be at standard temperature and pressure a liquid. We also have the nonmetal. That's a liquid. And that's bromine. Now there are no metallic gases, at least not at STP. And so the nonmetal gases that we have are these 5: hydrogen, nitrogen, oxygen, fluorine, chlorine, and then group 18, the noble gases. So these are my elements that are gas, solid, liquid. Here's some images of the elements at STP. I thought it's kind of cool to look at them and see what they look like. This is from a website, I think it's called theelements.com. Well, let's talk a little bit about the group numbers here and what their names are. And so you should know, for example, that group 1 is called the alkali metals. Group 2, alkaline earth metals. Group 17, the halogens. Group 18, the noble gases. And groups 3 through 12, transition elements. Now there are some important features that you should know about each group. Group 1, for example, you should know that they are never found uncombined in nature. They have the lowest ionization energies, electronegativities, and they have the highest atomic radii. Now each of these terms I'm going to go through, but I'm just listing this here. So these also always form +1 ions. Now I'll do some reactivity with you with these later on, but they give their name, or they get their name, alkali metals, because when you take one of these metals and you put them into water, they actually will form an alkaline solution. They'll form a basic solution. Group 2, again, they're never found never found uncombined in nature. And if I didn't make that clear, that means that they're always found in compounds. And they have, again, the second lowest ionization energy, electronegativity. And they have the second highest atomic radii. And these tend to form +2 ions. And something else that's important about them as well is that they're normally found in ores. So they have to be mined. A lot of these elements, in order to purify them, need to be mined. That's why they get their name alkaline earth. So I'm going to stop here because we're about at 11 minutes now. So next time I'll pick up, I'll talk about group 17, 18, some of the special atoms. And then we'll also get into some important things about, what do I mean in terms of atomic structure. All right, thanks so much.